Okay, welcome everybody who showed up. This is since this is the first of the talks are going simultaneously. I'm not quite sure how this is going to work out. There was a lot of good talks yesterday. And it was pretty easy to navigate, but I'm not sure. They told me to wait a little bit to make sure everybody got in where they're going. This is the intro to using single board computers and microcontrollers in Model Rocketry. So we want to get started. First, some housekeeping. This is your screen. Over here is a chat button. If this side window isn't open for you, there's a little arrow here. Click on that, and that should open it up. The chat window is basically for everybody who's attending to chat among themselves. I'm not going to be viewing that just because I don't multitask very well. The next tab over is the polls, and I will be using that. That's kind of like my main way of getting responses from you. Not quite sure what the people, I don't know if that is people who are registered or people who are currently in the session. I'm not quite sure about that. And the last tab over, the Q&A, is where you can ask questions. I'm going to try to monitor it as I'm going, but again, I don't multitask very well. Most of them I'll probably answer at the end of the session. So let's use that first poll. And what I'm going to do is it should show switch over to the poll tab. I'm going to launch the poll. You should see it. You have a choice of answers. I guess I can. There's a submit button. I was thinking. Oh, okay, yeah. Oh, so 32 people already responded. 3 people are here for the free beer. Well, if you want the free beer, you got to come to New Jersey. So, but I'm glad nobody answered no, because then you'd have to sort of go back out to the lobby and find the talk that you wanted. So I guess it doesn't tell me, just tells me percentage. It doesn't tell me the percentage of attendees who answered it. Oh well, I assumed everybody answered it. Very good. So we know how to use the polls. Who am I? If you don't know me, my name's Bruce Canino, member of the NAR. My number is 3. Oops, I even typed that wrong. It's 39989. Oh well. I am the Northeast Contest Board Chairman. If you're on the Northeast section, you're where your results go, and I approve them and post them to the scoreboard. My day job, I'm a senior software developer, and my night job is I'm an adjunct instructor, and I teach boot camp web development. And I'm also a ham radio operator, and my call sign is Kilo Delta 2 Lima Bravo Uniform. So, single board computers and microcontrollers. First, we have to talk a little bit about computers. Everybody should understand basically what a computer is. Even if you're not very computer literate, they they have a processor, and they talk about the speed and gigahertz and stuff like that. You have RAM or memory. Uh, this is where all the calculations are done. You have a storage device or devices where data is saved, uh, and a display and some input and output devices. So basically, it's this is what they invaded our life. No matter what you do, you pretty much at some point have to end up using one. And but there's different OSs, different manufacturers. But if you just kind of understand computers, like, do things, and they're like usually like multiple parts. And actually, I guess I missed the slide here, or maybe I didn't save it when I. Anyhow, basically, long ago, pretty much like anybody who has a laptop today has, it's basically inside a single board computer. There's nothing pretty much special about it, but that hasn't always been the case. Going back to the hobbyists. Oh, I got the slides out of order. That's um, um, uh, there was a separate board for everything. Like, here's the old S100 bus. If you ever watch the movie War Games, there's a computer that the the, um, the guy uses, and it was the first clone of the first S100 bus system out there. And basically, it just had a lot of slots, and each card uh, had its own function. I had a S100 bus system, and there was one card just for the processor itself. You had a separate card that had the memory on it. Um, uh, if you had a tape drive, there was a separate board that just controlled the tape drive. Um, so, and what happened was this was kind of nice because they were expandable and you could change things. But as computers got faster and the individual parts of the computer got faster, you were limited to whatever the bus speed was. So more and more, if you could get rid of the bus, uh, that was one of the throttling points. So single board computers came out, and they go back quite a ways. Here's an early. I'm not even sure what it is. I've never seen that one before, but there's lots of single board computers out there, and basically everything that you need, the microprocessor, the memory, the I/O, all the features of a functioning computer are just on that board. It's pretty simple like that. A microcontroller takes it the one level even deeper. Basically, what happens is a microcontroller is a whole computer on a chip. It can contain one or more CPUs or processors, along with the memory and programmable output devices. As such, usually they don't have quite as much power uh, or memory, but they're nice because they're all together in one small package. And that's basically uh, uh, the main difference between them. So here, it's sometimes good to go back in time to figure out where you're at now, but where did you come from? So now it's story time. And we're going to go back a long time ago. Back when dinosaurs roamed the earth and computer programmers made their living by chiseling ones and zeros into stone tablets. It was a primitive time. The internet didn't exist at that point. But there was a government agency, and it was called DARPA. And actually, DARPA, originally it was ARPA, Advanced Research Project. And then later on, they added the D because it was government funded. And it was mostly for defense projects, any type of technology they could use for defense purposes. They had the money to put their research out. And actually, when it was still ARPA, one of the things they did was they developed what was called the Arpanet. It was the first packet switching network to tie computers together. And basically, while we're here all online, the internet grew out of that Arpanet. One of the proposals that was submitted by a person, Guido van Rossum, the title of his paper was called Computer Programming for Everybody. And basically out of that paper, what he was suggesting was the computer language Python. I don't know how many of you've used it or not, but this is going to be important as we go a little bit further. Later on, and there's been a lot of computers and single board computers. But later on, and kind of almost in parallel with another process, the Raspberry Pi Foundation in the UK was put together. And basically, they they wanted to get computers into everybody's hands. And basically what they did was they came up with a single board computer that was relatively cheap and depending upon the time, right now they go around for $35. And basically it's just the board itself. You supply a monitor, a keyboard, and a mouse, and those are considered easy to get because a lot of companies and people have old computers and they can get donated to schools and such. So you have a pretty cheap computer. If you can get some old monitors and keyboards, you can get computers into the hands of people. One of the outgrowths, since they were so cheap and plentiful, was people started putting together projects with and they'd be like a whole self-contained project. And even down as simple as people take pies and they make them to what they call pie holes. Basically, you tie it onto your router, and it acts as a filter for all the computers in your house to block all the addresses, so you don't get any of the side ads and the pop-up ads and all that stuff. Also happening around the same time was a group of somebody came up. There was lots of microcontrollers out, and there still are. There's like things like the basic stamp. There's the PIC processor series, but they were all expensive. They required like usually expensive tools. So they put together a company that was an open source hardware and open source software in a project to use, and they built a basic microprocessor. And what came out of it was the Arduino. They also developed a development environment which caught on pretty popular, and that's really popular with Arduino development. But let's see, where did I want to go from here? So basically, so you had Python, where there was like a computer programming language for everybody. The Pi, we have actually computers for everybody. And basically what happened with the Arduino was it's microcontrollers for everyone. And actually, one of the things about the Arduino that really made it take off was the artist community got into it. And they make really small Arduinos that you can actually sew into your clothes, and you can power lights and have things move. And basically, it took if you get artists who aren't technical, but you can program them to do some basic things. You're basically putting these micro controller chips in the hands of everybody. So let's see. It's poll time. So I don't know if you attended a lot of the sessions yesterday. Almost all of them, at some point, somebody mentioned doing a microcontroller or a micro single board computer project, and they talked about it. Like, oh well, everybody knows this. In fact, if you got the latest version of Sport Rocketry, on page 6, there's an article on how to use the Arduino in as a flight recorder. So I'm going to ask a poll here, and it's about the Sports Rocketry magazine. And here we go. And I guess I have to actually take it myself. Otherwise, I don't get to see the results myself. Okay. Well, actually, I guess we have quite a few people who aren't NAR members. I wasn't expecting that much. Well, we have a good section of people who are about a quarter have already done this. No, this is pretty good. The results are changing. And actually, well, okay, yeah, I was at the this talk is kind of geared to the people who are answering the I want to make one, but I don't know where to start. But it doesn't mean that other people can't get any usage out of it. So, I wasn't quite expecting this type of results, but it's a good thing to know. Okay. I'm going to end that poll, and I have another poll. Let me get that started. And do you know? And it's do you know about C? No, actually, a very large percentage of the people. We got we got a ringer here. Maybe I'll. It doesn't tell me who answered that one, but that's pretty good. And actually, this is actually kind of surprising. I thought there'd be fewer yeses, but a pretty good percent. Whoa, yes, just took a big lead. And yeah, I like the. And we got quite a few C ringers here. All right, that's kind of cool. So let's see. Okay, I think probably pretty much everybody answered that. We'll go to the next one. Do you know Python? So I'll submit that. Okay, this is probably closer to the results that I was expecting. Although there's a good percentage of people who know Python. That's good. Okay, I'll end this poll. The next poll is: do you know how to solder? Wow. Quite a few people out there with rework stations. Oh. There's something I really didn't expect. I mean, that's well, that's also good to know too. Okay, so yeah, I'm pretty surprised about the results on soldering, but it is good to know. So, and in case if you're the of which end to you answer the which end is the hot end again. This is one of my favorite memes. Don't be this person. Don't grab the hot end. It's bad. So, okay, that was interesting. That was I like the results, even though I didn't expect some of them. So, the reason for my talk is electronic payloads for everybody. So this is a talk I've been sort of been wanting to do for quite a while, and I had it like in different forms. One was just kind of like do it as an Arduino kickstart to basically get people up and running to use Arduinos in projects. Because the technology to do it is out there, but the thing is, and it doesn't mean that there's not a lot of people out there already doing it. I mentored a team, the Temple team, for I forget which of these rocket contests it was, but it was they basically had to launch a payload which would land. They had a little rover that came out, had to collect the sample and go back to the payload bay. And I was mentoring them on the rocketry aspect because most of them were EEs and they were all doing the robot part. And they had one person who was really doing the rocketry part. And basically for him, his first rocket was this K-powered motor monster. And we did get to work through it. Well, we did get one good test launch, but then COVID hit and it put the kibosh sort of on that. And I'm not quite sure how they ended up. They ended up just doing the rover part for the contest. But I think there's a need for at least something that would, and there's interest out there to have electronic payloads for everybody. So I sort of made this talk about putting together a complete project that a person can put together, and it would require no programming on the part of the user, although apparently there's, people who've attended this already seem to know programming very well. It would also require no soldering skills. But apparently a lot of you already know how to do that. So that is not like a real big impedance. And the whole thing needs to fit in like a BT80 or less. My goal was for a BT70. And actually, looking at what I came up with, could actually fit in something much smaller. Definitely fit in a BT60 and probably a BT55. So basically, it was just a project. You could put everything together. But the thing was, so the question is, well, you come up with this project. Now, how do you distribute it to the people? And I could post it online, make a GitHub account, put all the stuff in, put some documentation, and probably some people, apparently most of you would probably be able to go out there and get it and actually do it. I was kind of heading in another direction. As being part of a amateur radio, one of the things our local club had was, we called it Tech Saturday. And basically a bunch of us got together on Saturdays. And it originally started off as just a show off. Like, we would come in with a a project we did and showed off to everybody. And then it actually started mutating a little bit. And basically we would pick projects where we'd all go out and buy a certain thing and all get together, put it together, and exchange ideas between each other and help people who knew one part and didn't know the other. So one of the things we did, we all went out and bought simple SDR dongles, and we went through the process of installing the software, configuring it, and it was really helpful for a lot of people. And even the people who were leading it would end up learning stuff out of it. So my goal out of this whole thing was to, since the advent of all these virtual events, that we could have among ourselves in the rocketry community a Tech Saturday, and stealing the idea. And actually, James Duffy will have a session later on about stealing. And to paraphrase him, I guess it's like good people or borrow and great people steal. Well, I'm stealing the Tech Saturday idea, and try it out to see if it would work in a Zoom meeting. Basically, what we do is come up with a parts list for the project. Everybody go out and get it, and then meet on Zoom and install the needed software and install the code onto the processor, the project, and just have a base reference. And then from there, you can take it and expand it to however you wanted. So actually, and I guess my last poll for the day is, would you be interested in having a session on Zoom that would do something like this? There's quite a few yeses. So I guess I hit the right audience. So let's see. So basically, I can show you stop sharing. So basically, here is basically what I came up with. It fits in a BT70. It has a Spark Fun Thing Plus. I picked it because I really like the ESP2 processors. It also had, in keeping with the theory of no soldering, it has the quick bus on it. And you can get a lot of the quick bus components. And actually in the article, because basically the article, was a data collecting article. Since I built this, I want to expand it to include the memory, the SD card recorder, and the other pressure sensor, and keep the OLED display so you can have some visual aspects when it's sitting in your tube. Also, I sort of worked on a little, it's almost the same project, and something we can do later. And it will basically run on a Raspberry Pi Zero. It's not much not much bigger than the SparkFun itself. There is a little bit of a problem powering the Pi. I just have a little LiPo battery, and the other reason I picked the SparkFun is because it does have already has the management for the LiPo battery. And with the addition of the quick connector, so you wouldn't have to end up soldering anything together. But most of the people here that wouldn't seem to bother them. The one thing I did have a problem sourcing was a on-off switch, which I was surprised. You just need a JST connector. You just need a JST connector with a switch, but I looked around and I didn't find anything. I thought they'd be pretty plentiful with the RC people. Maybe I'm just not looking in the right spot. If anybody who's listening knows about a source for on-off switch, it can be a slide switch. I'd probably prefer those rotating screwdriver type switches just for ease of access. But if anybody knows about one, let me know. And I can incorporate that into the project too. Basically, the way it works is let's see, how am I doing on time? I guess I should go to. I can skip that part. And since I have some slides that dealt with programming, if you're in that group that doesn't know how to program, this can still be for you. Because basically, what you could do is just load the base program onto it, and you have your data collecting project. And then you can go back and it's fairly easy to even if you don't know C, it's pretty straightforward to make even minor changes or add a different module and copy and paste. And we, if that Zoom meeting Tech Saturday type thing catches on, it can be part of that. So let's see. Yeah, I guess I should go over and check the questions and answers and start doing that. Anybody? Let me take a look at the chat. No questions? It says you have not created any questions. Maybe I need to create one to see it. Okay. Well. Hey, James. So basically, it's what it's going to be is the article in Sport Rocketry. It's a data collector. It would collect temperature and barometric pressure readings. But it could be expanded. You could put any of the sensors that, three-dimensional sensors and record that data. from the best I can tell in the article, the way you transfer data is through the SD card. But by using the Spark, using the ESP32 chip, you could just transmit the data directly to your tablet or phone instead of having to pull the SD card out and grabbing the data. Can you show details of what we can do with this stuff? Actually, yeah, I guess that was again, it was more of this was for more intro to how to get started, but I think that there's a big need for this. What you can do. So the everything for this project is geared on reading input from sensors. So like if you're in TARC, and you could collect all your flight data profile to a much greater detail than what you get out of the. And actually, one of the things I put on the backside of this was a peanut. So basically, I can collect the data off of this too, and check it with my pressure sensor, and actually calibrate my software to, if I was using this for my TARC rocket, I could calibrate my sensor to it to perform other functions. You can move servos. TARC isn't allowed to use any pyrotechnics, but you could control if you're doing was it SB2 flights. You can do pyrotechnics in that, so you can sort of control where your ejection charge is. You can control your parachute, other things like that. No, I didn't do the article on in sports rocketry. Who did? I'm gonna Mason Stang. He did the original article. I just I got my sport rocketry magazine myself maybe 2 weeks ago. But actually, I'm going to try to publish a different type of article. It's not dealing with a payload, but it will be using a Raspberry Pi. I like to build a test stand with a load cell and a transducer. Yeah, actually, that would be a good choice for a Pi. You can probably do it with a microcontroller too, but in this case, like a Pi, you do have the general input-output pins. The input can be either analog or digital. With a load cell, it would be like you'd be reading an analog resistance. So basically, you tie it to one of your tie it to a GPIO pin for input, and just have it read the resistance, and then you need to calibrate it to something, and then you can write a program to record the data. And actually, this would be a good thing for Python. Actually, one of the stories about the Pi itself was, and I don't know if this part is true or not, but it was called Raspberry because, in homage to the early computers that were all named after fruits and stuff, and Apple being the biggest out of it. But the Pi part, depending upon who you listen to, the original version of the Pi was only going to run Python. But that didn't come to be. Fortunately, they ended up having their own Linux-style OS. But even now, you don't even have to stick with the Pi OS anymore. There's other distributions that run on the processor. You can run CentOS. So anything that you're already used to, it'd be available. If you want to catch up later, ESR user 1, maybe we can chat offline about it. But it should be fairly straightforward if you're in the group of. I can at least point you in the right direction to get that done. Does that answer all the questions? Well, I hope you enjoyed this. And I finished on time and not running over. So I think I accomplished 2 of my goals. I don't know if if you're interested in doing the project, I guess the best way is you can contact me. Maybe what we'll do is put together a meeting of the people who are interested and actually decide what the first project is and go from there. I guess I didn't think this part out too well. You can just send it to Bruce Canino at gmail.com. Tell me that you're interested. I'll put together in the next couple of weeks or so. We'll put a Zoom meeting together, talk about it, and change the project to suit what you want, and see if this works out. So I guess that's pretty much what I've got. I'll hang around here a bit longer if anybody else has any questions. But you do have time to prepare for the next talk. I'm also supposed to wait a certain amount of time before actually stop broadcast because there's some latency issues in the software. How do I start? You mean getting actually probably one of the easiest ways to get started, depending upon, you go on the internet and there's lots of these all-in-one kits. They come with a base Arduino and pretty much all the sensor parts that you want, and they usually come with a breadboard, so you can start putting them together just by running the jumper wires. And then for each of the sensors, there's already a library. There's a library out. How to? I'm sorry. I'd like to clarify. I would like to do this. Okay. Yeah. Okay. Yeah. I'll take your name down here, and I'll try to get again. Probably it's easier just to email me at brucecanino@gmail.com, and we'll try this Zoom meeting thing and see if it works. Could you please show the kit again so I can get a screenshot? Is he talking about this? There's a ton of them. You go on Amazon. Yeah, the Uno is the original kind of Arduino. They all have a base footprint, and they're standard. For Arduinos, they call them shields that you can stack on top of each other. But this isn't a Uno. This just happens to be a ATmega. But yeah, for the base compatibility, that would work. But they all share like the same I/O pins. If you transfer it to like another project, sometimes you do have to change the pin assignments because the boards don't always have the same pin assignments.